Einstein's theory of relativity is explained about time dilation. That means the moving clock nearly moving with the velocity of light, that time is slowed down in the clock. I already explained that Einstein time dilation is wrong. The appearance time is variable is depend upon the distance between source and observer and a relative velocity between source and the observer. In this video, I explained the time variation. Welcome back to our MTR YouTube channel. Our MTR theory is explained that time is constant throughout in our universe. The time interval between the two incident is always constant. When the observer and an incident or rest respect with ether medium. Let's consider a light source is send the light pulse throughout all the direction. After the 5 second, once again it will send the another pulse. This light source is rest respect with ether medium. At the same time, large number of observers are present in our whatever place on the universe, and everyone rest respect with ether medium. Then every observers are measure the time interval between the two light pulses are exactly same as 5 seconds because time is absolute throughout the universe. Absolute time is constant throughout the universe, but appearance time is variable, is depend upon the distance between incident and observer. Let's consider two light explosion E1, E2 or takes place in our galaxy. Both explosions are separated by very long distance compared with velocity of light per second. One of the observer O1 center line of this both explosion. Observer 1 is seen the both explosions at simultaneously. The time interval between these both explosions are 0. We consider another observer O2 is away from explosion E1 and near to explosion E2. So according to these observer, the time interval between these both incident is a particular value, not equal to 0. We consider another observer O3, he is near to the explosion E1. So according to this observer, the time interval between these both explosions also not equal to 0. Therefore, the time interval between the two incident is varying from observer to observer when they are separated by different distance from the incident. This time difference between two incidents is arise due to the explosions or takes place in the different places. If both explosions are very near to each other, then this time difference between the two incidents is remains constant throughout universe. The appearance time interval between the two incidents is vary also respect with relative velocity between source and observer. Let's consider observers O1, O2, O3 are having the atomic clock C1, C2, C3 and they are placed on the point P. This point P is placed in the ether medium. All the atomic clocks are very accurate up to nanosecond. All the clocks are synchronized with each other. That means they are showing same time. All the atomic clocks are having one transmitter and one receiver. These transmitters are sending the light signal each and every second, and also the receivers are receiving these signals from other clocks. In this first case, all these three clocks are rest at the point P. Every clocks are sending the light pulse and receive the light pulse. The time interval between sending and receiving is becomes 0 because all the clocks are very closer to each other. In second case, observer 1 is present at the same point P, but observer 2 moving along the direction of plus x-axis with the velocity of c by 2. Initially, both clocks are coincident at the point P. Both are simultaneously send the pulse. After the 1 second, observer 2 has reached the distance cd by 2. Then both clocks are sent the next light pulse and continuously propagate along the positive x-axis direction. After the half second, the clock pulse sent by C2 is reached the clock C1. According to the observer 1, the time interval between the two clock pulse of the clock 2 is 1.5 seconds. Second clock pulse of the first clock is goes to reach the second clock at the end of the second. Within this time, it will be travel the distance of CD. So according to the observer 2, the time interval between the two successive clock pulse are 2 seconds. 2 seconds in the clock 2 is equal to 1 second in the clock 1. Clock 2 is slowed down by 1.5 seconds, but clock 1 is slowed down by 2 seconds. This difference is arise due to clock 2 is moving, but clock 1 is at rest. Einstein theory of relativity is explained fast moving clocks are go slowly, but MTR theory is explained that both clocks are go slowly. In case 3, the clock 2 and clock 3 both are moving away from each other. The time interval between the two clock pulse same as in previous case. Now you will get both clocks are equally slowed down. This is something different from Einstein time dilation. In case 4, the clock first is at rest, clock 2 and clock 3 are moving away from each other. After the few seconds, observer 2 and observer 3 are come to rest. The distance between the two observers are constant. If you are measured the time interval between the two clock pulse by observer 2 and observer 3, both are exactly same, that is equal to 1 second. From this scenario, whenever the clocks are moving away from each other, time is goes to slow down. The relative distance between the two clocks are constant, then time dilation is become 0. That is, the clocks are run normally. In fourth case, observer 2 and observer 3 moving towards each other, then the time in the clock is moving very fast. Observer 2 and observer 3 or observe the time interval between the two clock pulses are shorter than 1 second. Rate of time dilation is depend upon relative speed of the two observer, and amount of time dilation is depend upon distance between the two observer. Einstein theory, only fast moving clock goes slow down, but MTR theory is explained clock at rest and moving clock both are go slow down. In case 5, observer 2 and observer 3 are move away from each other. Time in their clock is slowed down. Both are moving towards each other, then their clock is move very fastly. If both observers are meet at a point P, then the time in the all the clock are exactly same, not different. We are know three things from this thought experiment. First one, if two observers are moving away from each other, then time is slowed down in opposite clocks comparing with their own clock. If two observers are moved towards each other, opposite clocks are moved faster than their own clock. If the relative distance between the two clocks are constant, then time variation is become 0. If two astronomers are make space travel from a point, they are travel with whatever velocity, whatever distance, whatever years. Once again they are meet with each other, their clocks are showing same time. Appearance time only varying from observer to observer, but absolute time is always constant throughout the universe. From this thought experiment, Twin paradox thought experiment, and time travel are not possible. Thanks to watching.